Good evening. What's up, Zoran? Ah, don't really need this one. I wasn't actually in Zagreb. I was about 300 kilometers away. And it's usually not trafficy, but since we had a holiday, um, I don't know if it's celebrated on the 1st of May in France as well. How do you call it in English? French, maybe? I don't know. It's when people don't work, holiday. Labor, something? I don't know. Praznik rada. Praznik rada. Labor Day, yeah. Labor Day? That I mean, I understand the translation, but it doesn't line up properly. The day of labor. So it's the day when you work, right? I don't know. It sounds better in Croatian. I have a house in a village. I need roughly 5 hours to get there. It's very hot right now, so that's why the hat goes that way. The traffic on the way back to Zagreb was really high because everyone is going back home to Zagreb. Everyone was on a vacation for 4 days because the Labor Day was on Thursday, right? And then you have Saturday and Sunday as a weekend, and then you have Friday, which everyone like bridges with the weekend, right? So it's a 4-day holiday. No, not weekend. It's a village house. My parents live there. Instill energy. What up? What up? Here only the manual labor jobs work on Labor Day. Yeah, here basically just McDonald's works, I think, and some of the how do you call them? What is the unique name uh for coffee bars and restaurants and I don't know. My brain is fried. Out in the country, yeah, I told you it's a village home, literal village. Ice blade, what up? What up? No, no, no. Coffee bars are not fast food. Coffee bars are where when you drink coffee, right? So any one of you who speaks Croatian, the word I'm looking for in English is ugostiteljstvo. So, what is the translation for ugostiteljstvo to English? Maybe we can check it out. Hospitality? Okay, okay. Yeah, so the hospitality services usually work on any holiday or similar, right? Those are the days when the money money income is higher in these places. That here is a little bit of a NAS upgrade. Not sure how visible it is. It's not really visible, is it? From the chat. Oh, it's better. So we need to nice and be on top of it. I'm very tired, but I'm gonna get my energy back any minute now because 7 hours of driving is it's a little bit drainy, but when you're focused on the road for way too long, the longest I was able to drive Forza Motorsport, a video game, right, was 60 minutes. 60 minutes of racing. And it really drains you, even if it's just a video game, right? But you pay attention to not crash the car, because if you do, then you lose, right? In real life, it's not about racing, but it is about paying attention to the road, right? So it's not that much different in terms of having a focus on what is in front of you for quite a long time. So, where were we the last time? This is the yeah, that's where we are today. That's where we are today. I can smell the food coming from the other room. So my wife is clearly making something, and I'm not sure if I am worthy of getting any of that food, but we'll see. We'll see. I know for sure that my daughter is now getting some food. We'll see if I'm worthy of getting some as well. Let's start. Let's start slow today and see how that goes. Does this lesson have two parts or just one? Oh, it seems to be easier. One. Okay. Okay, let's give it a go, right? So modify process execution priority. Oh, that's why you said so we need to nice and be on top of it. I wasn't even reading the topic. Know the default priority of a job that is created. So that one is supposed to be 0, if I'm not mistaken. Run a program with higher or lower priority than the default. Okay, change the priority of running process. Is that all? Is that all? That kind of seems less than 1 of 1. Nice. I'm actually glad that this is just one lesson and the weight of the lesson is number 2. Goody goody. Okay, let's try to read this. Operating systems able to run more than one process at the same time are called multitasking or multiprocessing systems. Whilst true simultaneously only happens when more than one process unit is available, every single processor systems can mimic what is this word? Simultaneity by switching between processes very quickly. This technique is also employed in systems with many equivalent CPUs or symmetric multiprocessor systems, given that the number of potential concurrent processes greatly exceeds the number of available processor units. In fact, only one process at a time can control the CPU. However, most processes activities are system calls, that is, the running processes transfer CPU control to an operating system's process so it performs the requested operation. System calls are in charge of all inner device communication, like memory allocations, reading and writing on file systems, printing text on the screen, user interactions, network transfers, etc. Transferring CPU control during a system call allows the operating system to decide whether to return CPU control to the previous process or to hand it to the another process. I think my noise gate is... Can you actually hear me? La 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 la. Can you hear me, guys? Oh, that's very weird. The reason why I'm asking is because I am used to having a microphone, but now I see that it's below. That's why I couldn't see it. It was below. Sorry about that. Anyways, I think my... Yeah, I told you I'm tired. I think my noise gate is fairly well set up, but I do have my window open behind me. And this is kind of a main road behind me, so if you start hearing loud cars, let me know, so then I will close the window. The reason why it's open is because I'm really hot. I burned out and I'm trying to cool down. Yeah, now the cars are passing and I can see the VU meter is not jumping on them, so that's good, I suppose. As modern CPUs can execute instructions much faster than most external hardware can communicate with each other, a new controlling process can do a lot of CPU work while previously requested hardware responses are still unavailable. To ensure maximum CPU harnessing, multiprocessing operating systems keep a dynamic queue of active processes waiting for a CPU time slot. I hear no background noises from the window and I have headphones on. That's good. That's good. Although they allow to significantly improve CPU time utilization, relying solely on system calls to switch between processes is not enough to achieve satisfactory multitasking performance. A process that makes no system calls could control the CPU indefinitely. This is why modern operating systems are also preemptive. That is, a running process can be put back in the queue, so a more important process can control the CPU, even if the running process has not made a system call. The Linux scheduler. Linux as preemptive multiprocessing operating system implements a scheduler that organizes the process queue. I think the text so far is a lot more complex than they said it would be. Like they said, the weight of this lesson is 2, and it might as well be a level 2 difficulty in the form of practice round. You know, the thing that we are going to actually do hands-on. Hands-on is probably going to be easy, and there will be, it seems to be a lot of reading, right? But for I don't know how many of you are in the chat who know very little about how CPUs work, but basically Iceblade says, yeah, more hardware knowledge is expected of this one. Yeah, so it's not very easy to transfer this text so far, and I'm sure that Iceblade and someone else who hasn't even said anything in the chat so far, I'm sure there is someone who is a bit foggy on the text so far, but what is fairly important is how multitasking works in the CPUs, right? So CPUs can't do multiple things at once, basically. I mean, at least a CPU core cannot do more than one thing at the time. Even back in the day when we only had a single core in every processor, right? That while we didn't still have multi-core CPUs, they were still able to multitask. But the CPU actually cannot multitask. The operating system is the one that can multitask. So that's the difference that is important to be aware of. So the text that we have read so far is trying to explain how the operating system is the one who is basically, how do I put it? You run processes on a multitasking operating system, such as Linux. So you give it. I'm trying to simplify, but I lack the. For example, what I'm doing right now on my computer, I have OBS doing something. It is probably using one process to record this, another process to record the camera, another process to encode this video in real time. There is another process on a web browser that I have on my left screen here that I use to read your messages on YouTube. Another process that is another browser on a Twitch web page. Both of them are running at the same time. I don't know how many of the tabs is being run in the background. I just leave it up to the web browser to decide. But also the KDE is doing stuff in the background. The systemd is doing a lot of stuff in the background. So basically, I have like, let's say 200 processes going on at the same time. Some of them are more important, some of them are less important, but let's pretend that all of them are equally important, just to simplify things. So you have like 200 processes running at the same time, right? But some of the processes really need more CPU power. Some of them need very little CPU power, but all of them are wanting to run at the same time, right? But this now depends on how fast the CPU is. So you have some kind of a queue. That's what we were reading in the lesson so far. You have a queue of the processes, all 200 of them are coming into the queue, and the operating system, basically the Linux kernel, is deciding, okay, let's give a time slot of microseconds, literally, to OBS capturing this microphone. And this is some process that needs a real-time processing, because otherwise it would be choppy on your end, right? So the kernel understands which process needs which kind of priority, let's say. I'm really trying to simplify, but it's not that simple. So it comes into the queue, and the kernel gives it to the CPU to chew on it, but the CPU is very fast. And in my case, I also have more of them, right? I have 8 CPUs. So the kernel gives something to the first CPU, and then another thing is coming into the queue. It gives it to the second CPU, and it basically hands out some of the tasks for the CPUs to to chew on, right? To work on it, and this lasts for microseconds. And then the CPU says, okay, the microphone doesn't need to work now. Let's give, I don't know, systemd wants to do something in the background. Let's give some CPU time. This is important. The word, the phrase is CPU time. Let's give a little bit of CPU time to the systemd. Systemd needs to do something. So the microphone is now on hold. But why you hear me without any, how do I put it? Why is my sound not interrupted? because everything the computer does is basically being broadcasted in packets. The packets are, for example, the sound. The easiest way I can explain to you how sound is being sent over the internet is by, well, in my day job, I work with voice over IP equipment, VoIP, basically. So I will just turn us in a minute to explain how VoIP works, and then you will have an easier time to understand how CPU works. So when you have a phone call, for example, you talk via WhatsApp or Telegram or Signal or whichever the voice over IP application you prefer to use, and you use it to make a phone call to someone on the other side of the internet. Between your device and their device, there is a TCP IP network. It doesn't matter that it is called internet. It is TCP IP. So depending on how the program is configured, it will send, it will record your voice for some time, okay, and then it will send this packet like encoded into the TCP/IP packet. It will send it over the network, and while it is sending it over the network to the other side, it will automatically continue recording the next packet. But the recording of my voice is happening for this amount of time. It doesn't matter how long it is, but let's say the recording of my voice is happening this amount of time, and when it how to put it, when it encapsulates this voice packet into TCP/IP, sending this packet over the network takes this amount of time. Okay, so it records for this long, but it only takes this amount of time to send it to the other side. Do you understand how this works? So the other one who is listening to what you're saying, he is listening to this long, but the next packet has already arrived because the internet speed is very fast, and it only takes this amount of time for the next packet to arrive. So basically, the packets are coming like throwing a ball into the other side. And why I am describing a network, how network packets work, because in order for a network packet to traverse to the other side, you also need a CPU to capture your voice and to encapsulate this voice, this amount of voice time. The CPU needs to put it somehow into the TCP/IP packet. CPU needs to work together with the network card in order to send it away, on the internet. There is a lot going on, and the reason why all of this seems to be working in real time as a multitasking operating system is simply because the CPU is really, really, really fast. That's the whole idea behind everything. You have multiple thousands of megahertz available on each one of your CPU cores, and each one of your CPU core is giving just a tiny bit of CPU time to every process individually. Basically, every CPU core is working. If you would slow it down, like in Matrix, it would look like the CPU is doing working with this process, okay, and then putting it back, and then it's working with this process and then putting it back, and then it's working again with this process and then putting it back. But these processes are so slow in terms of what they need from the CPU that they don't even notice that they have been put down for a little while. That's how CPU is fast, and that's why it appears to be that the CPU can work with 200 processes at the same time, but in fact it can only work with one at the same time. if it's a single core CPU. In my case, 8. And I really apologize for talking for so long, but I just thought that it would be good if I would stretch these a little bit, because the way that this PDF was written was slightly too technical. Iceblade asking, could be compared to YouTube buffer but smaller. Yeah, that's the same. That's the same. That's literally the same thing. Zoran is asking, can you say that an 8086 CPU and the brand new Core i7 work the same, but only a new i? Your sentence is a little bit weird. You're comparing an old single core CPU with a modern 6-core CPU. I don't know how many cores do i7s have these days, but basically, if the modern i7 would have just one core, then this CPU could do a lot more multitasking than the old 8086, simply because it's a lot faster, and the queue in the kernel, in the operating system, is basically doing the multitasking. That's who is doing the multitasking. The operating system is, not the CPU. And the only multitasking the CPU is doing is having more cores. That's basically more CPUs. So from that perspective, yeah, the new CPUs are simply much faster. That's it. And having more cores, meaning more CPUs. Iceblade says 8086 in megahertz range, right, versus Intel 5-ish gigahertz. I have no clue what that means. .8086 is a really old CPU. Clock speed comparison? .8086 had like 1 megahertz, maybe? I don't know, we can ask the internet. Oops. 1977, let's say. Maximum clock 5 to 10 megahertz. I'm just searching if there is an example of typical clock speed. Okay, let's say 5 megahertz. .8086 didn't even have protected mode, only real time. Well, I lack a lot of knowledge about the old CPUs. I did have Amiga computer. I still have one. Amiga was kind of interesting in terms of multitasking. Amiga operating system kind of pretends to be able to multitask, but basically when you switch from one task to another, let's say you have two windows in your operating system, when you switch to a different one, the old one basically sleeps. It does still take up the RAM, but it just sleeps. 1000 times difference if you compare to a single core only? No, a lot more. A lot more. There is also a thing called sorry, I'm so screwed up today. IPC, instructions per clock, in CPUs nowadays. This is being increased in every single CPU generation constantly. So basically, if you have a 14th generation of i-core processor, it has more instructions per clock than an older generation of the CPU. So basically, for each megahertz, you can give it more instructions. Does it say how many instructions per clock? Yeah, I'm sure you can you can find that information online. Let's I don't want to search internet for too much. Let's try to ask the stupid AI. Just a rough number to get a good grip. It doesn't know. Okay, whatever. I don't want to diverge the path of today's lesson that much, but suffice to say that you have instructions per clock, which is higher on the more on the newer CPUs than it used to be on the older ones, even from the 2 years ago, right? So it always improves. It always improves. So if you have a Ryzen from the last year, and it has the same amount of gigahertz than the one from 5 years ago, right? But it's faster. It's generally faster, no matter that it offers the seemingly same amount of gigahertz. It is. Where were we? Linux as a preemptive multiprocessing operating system implements a scheduler that organizes the process queue. More precisely, this scheduler also decides which queued thread will be executed. A process can branch out many independent threads, but process and thread are interchangeable terms in this context. Every process has two this is rough English for me. Every process has two predicates that intertwine on its scheduling, the scheduling policy and the scheduling priority. There are two main types of scheduling policies: real-time policies and normal policies. Processes under a real-time policy are scheduled by their priority values directly. If a more important process becomes ready to run, a less important running process is preempted and the higher priority process takes control of the CPU. A lower priority process will gain CPU control only if higher priority processes are idle or waiting for hardware response. Any real-time process has higher priority than a normal process. As a general-purpose operating system, Linux runs just a few real-time processes. Most processes, including system and user programs, run under normal scheduling policies. Normal processes usually have the same priority value, but normal policies can define execution priority rules using another process predicate, the nice value. So that's our lesson. To avoid confusion with the dynamic priorities derived from nice values, scheduling priorities are usually called static scheduling priorities. The Linux scheduler can be configured in many different ways, and even more Intricate ways of establishing priorities exist, but these general concepts always apply. When inspecting and tuning process scheduling, it is important to keep in mind that only processes under normal scheduling policy will be affected. Oh, you can hear that. I'm gonna pretend that this is my dinner. Reading priorities. Linux reserves static priorities ranging from 0 to 99 for real-time processes, and normal processes are assigned to static priorities ranging from 100 to 139, meaning that there are 39 different priority levels for normal processes. I think you already know where this leads to, these numbers, right? Lower values mean higher priority. The static priority of an active process can be found in the sketch file, located in its respective directory inside the /proc file system. Okay, so this is the moment when we fire up the command line. Let me just check. Is the IP address of my demo? I keep forgetting. IP address 206. Okay. Okie dokie. Let's do the command. Okay, I don't know what this sign here is. So let me try to remind myself. Not a part of grep. Who knows what this sign is? Beginning of line. Let me test it without it. So the same result. Okay. Okay, good to know. So this sign basically says, if I understand you correctly, that what we are searching for must be in the beginning of the line. Yeah. Prots 1 sketch 120. As shown in the example, the line beginning with prio gives the priority value of the process. The PID 1 process is the init of the systemd process. The first process, the kernel, starts during system initialization. The standard priority for normal processes is 120, so that it can be decreased to 100 or increased to 139. The priorities of all running processes can be verified with the command ps. What is the difference? The priority column. The priority, I suppose it's priority, PRI column indicates the static priority assigned by the kernel. Note, however, that the priority value displayed by the PS differs from that obtained in the previous example. Due to historical reasons, priorities displayed by PS range from -40 to 99 by default. So the actual priority is obtained by adding 40 to it. In particular, 80 plus 40 equals 120. Okay. Okay. 80, 60. Interesting to note that the one that is 20 below the one that is 80 is also -20. Nice. Nice is -20. But the one that is -40, that one doesn't have a nice value. I'm just checking. I have never really used the priority column, just the nice one. But apparently, if the priority is 120, that's the nice value of 0. Maybe I'm wrong, but it definitely seems that way. So if we want to go down to the higher priority, that is 100, it would say 60 here, but that's basically -20 nice value. I'm pretty sure I got it right, but someone can kick me in the face if I'm being mistaken. Okay. The PRI column indicates the static priority assigned by the kernel. Okay, it is also possible to continuously monitor processes currently being managed by the Linux kernel with program top. As with the PS, top also displays the priority value differently. There is some possible confusion here. Higher priority value means lower actual priority. It shouldn't be confusing because it already said up there somewhere that the lower... We already know from before, from previous lessons, that the lower nice value means higher priority. And it also said somewhere here, we just read it. Lower means higher priority, right? So it's all clear. It's all clear here. It shouldn't be. Thank you for saying this, Alexei. But I think for everyone else in the chat and those watching video on demand, I think it's fairly clear by now, because we already, as I said, we already went through the nice values previously, and it said -19 is the highest possible priority for normal processes. Logic-wise, it's not low equals high, but I think it will sit. I understand. Yeah, Alexei, I now understand what you meant. Yeah, I did mean higher priority, but Yeah, lower number. I me personally, I wasn't confused, but now I see how it came out of my mouth. Where were we even? Somewhere about here. It is also possible to continuously monitor processes currently being managed by the Linux kernel with program top. As with PS, top also displays the priority value differently. To make it easier to identify real-time processes, top subtracts the priority value by 100, thus making all real-time priorities negative. With a negative number of real-time, is this real-time identifying them? Therefore, normal priorities displayed by top range from 0 to 39. Why not make it confusing to everyone, and why not give people 3 different scales that do the same thing? Okay, let's see it. Priority. Okay, so top has priority 20. So that's basically nice of the value 0, right? So the middle one, the default one. But yeah, the ones that are 0, those are no longer normal ones. Nice was just the value of set correct. Iceblade, can you please write longer sentences? I get a little bit. I want to answer your question, but I'm not always able to decipher what you mean. Alexei says, let's subtract random numbers from priority values in each utility if actual priority values were not confusing enough. Yeah. Okay. But at least the nice value may be a common value between these, at least for the standard processes. Oh, Iceblade, don't think about nice values just yet. We haven't arrived at the part of the lesson that is talking about nice values just yet. Give it time. We are now talking about the actual priorities, and they are different from nice values because nice values only apply to normal processes, not to the, you know, it is confusing. Let's let me read this entire. What is this? How do you call this? Let me read this from here. I think it's worth reading one more time. Linux reserves static priorities ranging paragraph. I think this is paragraph, right? But okay. Linux reserves static priorities ranging from 0 to 99 for real-time processes. Okay, this is important. For real-time processes from 0 to 99. Normal processes assigned to static priorities ranging from 100 to 139. Okay, you will see later when we get to nice values that they are playing in this ballpark here. If you remember from the previous lessons or lesson, nice values had value. They had 39 values. The 0 was the default one, and you could increase the priority by nicing the process to the negative value up to, I think, minus 19. And you can go up to 19, but this lowers the priority. All in all, you get 39 of them. 0 plus 19 plus 19. So those are the static priorities for normal processes. For normal processes, you can use the nice value to re-nice them, basically. Minus 20 is the last one. Okay, sorry about that. Okay, so it goes up to minus 20 is the highest possible priority, right? When you go to minus 20 with the nice, let's say, command, because you can use the nice command to re-nice the priorities, right? If you go to minus 20, that's the highest you can go. The kernel itself can go higher than minus 20. It can go to, let's say, minus 21, but it's no longer called minus 21 because the nice value cannot go that high. Then you're entering the territory of real-time processes. So once you nice the process to minus 20, anything higher than that is the Linux real-time process starting from 99. I know it's confusing, but it starts with 99 and goes up to 98 and 97, you know. It may start making sense after a while. It's a matter of practice. As Alexei said previously in the chat, it's not just that Linux has priorities ranging from 0 to 99 for real-time processes and 40 of them more for the normal processes. So altogether, it's like 140 priorities, but also the PS command shows them differently, completely different numbers. And the top command shows them in a third way. Nice values should have started from 69. But yeah, let's go back to... I'm trying to decide what is important to repeat. The standard priority for normal process is 120. That's the nice value of 0. Okay. The yeah, this part is important. The priority value displayed by the PS command, I have read it already, but it's worth repeating. The priority value displayed by the PS command is different, and it goes from minus 40 to 99. So the actual priority is obtained by adding 40 to it. So if the PS command tells you that the priority is 80, it's actually 120. It's like you are in high school on a history class and you have to learn things sometimes without making too much sense of it, right? It is what it is. Also, it is also possible to read the priorities with the top command, right? But this one shows it in a third way. Top subtracts the priority value by 100, thus making all real-time priorities negative. It kind of makes sense but it doesn't. With a negative number or real-time identifying them. Therefore, normal priorities displayed by top range from 0 to 39. Okay, so if you see that the top is showing you the priority 0, this means that this is a normal process and the nice value is -20. Did you remember all of that? Maybe it would be a good idea to draw a small table. Table? Is it called table? I suppose table with 3 columns, like Linux, PS, top. So you can see where they line up. Iceblade is asking, so 20 would be like 120 in top. You need to ask me 20 of what program would be like 120 in top. Do you mean 20 of PS or 20 in the kernel? But let's go ahead and forget that we are now having some amount of brain fog with these conversions, and let's continue to reading about the general state of things. Gotta remember all those. Yeah, I think we did good so far. It doesn't matter that much that you remember them forever. I think it's worth remembering that these utilities display priorities in different ways. I think this is enough in the long run, because when the time comes that you need to know the exact priority as the kernel sees it, then you will remember, oh yeah, they are different. This is not what it seems to be. I just need to check on the search engine what is the difference, and it's enough to be aware that there is a difference. That's my opinion. You don't really have to remember them all. Also, most of the times as a user and as an administrator, I believe that you will be working with nice values for the most of the times. And nice is always nice. It always goes from -20 to +19. So that part is not going to be confusing. I'm just saying. Zoran says, fun. You could start Tmax and have side-by-side screen with top and htop. Do I have to? Iceblade says, I assume it's +19 as max because it counts number 0 as one of the numbers. Yes. Yes. PS-E-O user UID com TTY PID PPID. Okay, it's sorted differently. I'm not gonna pretend that I remember all of these commands. I mean, I remember them from previous lessons, but very foggy. I would have to enter the manual each time to remember what this one is, what this one is. It's when you don't do it in regular practice, it just falls out of the muscle memory, right? Now the fun part comes. Process niceness. How nice is your process? How nice are you being towards your process? Every normal process begins with a default nice value of 0, which is priority 120 from the kernel perspective. The nice name comes from the idea that nicer processes allow other processes to run before them in a particular execution queue. So please, after me or before me, I did it wrong, did I? But yeah. Nice numbers range from -20. Less nice, higher priority. To 19, more nice, low priority. Linux also allows the ability to assign different nice values to threads within the same process. The NI column in PS output indicates the nice number. Only the root user can decrease the niceness of a process below 0. It is possible to start a process with a non-standard priority with the command nice. By default, nice changes the niceness to 10, but it can be specified with option -n. Throughout my Linux life, I didn't use this command too many times. When I was younger, I thought that I could speed up some things. When the server is busy, I thought that I could speed up some. When the server is doing multiple things, right? It's a bit busy, and the load average is a bit high, and I want my stuff to be done faster than some other stuff. And I thought to myself, if I decrease the nice number, so the process is less nice and thus gets the higher priority, I thought that I could somehow queue up my process to, well, finish faster. But most of the times, from my experience, I would just end up raising the load average even higher and pretty much screwing up the entire computer. So be careful about nicing the process and what the process is actually doing. However, if you're doing this, for example, if you need your computer to serve you like it always serves you, but I don't know, you want to encode some video in the background or stuff like that, and you really don't care when the encoding is going to finish. You just want it to, start happening, and eventually it will finish. But you need your computer to be available for you in its full glory, power, whatever, right? So you can start your encoding process and then nice it to the value higher than 0. So the encoding process is going to be, it's going to be happening whenever everything else is not happening, pretty much. That kind of nicing will never slow down your computer by any means, and it's useful if you need to get something done what takes a lot of time. That's how I usually do it, right? For stuff that takes time, like encoding videos. Could be useful for data science. You mean putting a higher number than 0 or lower than 0? What do you mean? I'm not sure what the data science means in your head. What I was saying is when you have some kind of a CPU task that needs to be done eventually, and you want it to start now, so it's finished as soon as possible, but you actually need your computer for something else, for example, for streaming. I could run encoding a movie right now. I could run it right now on my computer and put a higher nice value on it, and the encoding would not interfere with my streaming. That's what I'm saying. The encoding would still happen. It would just be a little bit slower because the encoding would be happening while my OBS doesn't need my CPU. That's what I'm saying. Damlan Trap, hello. Iceblood says, I meant that you could change priority depending on timing, on time-sensitive things. We'll get to that. Only the root user can... Okay. Nice dash N15. Okay, so we are basically starting the tar process, and we are archiving the entire home partition, but we are giving it a niceness of 15, so that's pretty low, but it will do a big job, right? Because home is something big usually. Not on this server though. See how big is it? 1.2 megabytes. So let's do it on my computer maybe. Not sure if that's a smart idea. Oh, we can try it. Okay, let's watch it. So right now, my load average, Alexei says F. Right now, my load average on my computer from which I am streaming is 1.5. OBS seems to be using the majority of my CPU. The nice value of OBS is 0, like most of the processes. Pipewire is apparently a real-time process. Let's go here and let's go to the temporary directory. So let's back up the home folder. Mind you, this folder on my computer is half a terabyte big, I think. So there we go. Now let's see what's happening. So the gzip has started with the niceness of 15. You can see it here. I'm trying to increase my pointer size. But you can also see that my load average is not really increasing. Alexei says, isn't the temp mounted as temporary file system in RAM? I'm watching the memory allocation. Could be. I'm watching the memory allocation here. It is growing. Yeah. But also load average is increasing. But not too much. Beware of whom. I'm gonna stop this, but all I wanted to say is that this process cannot hurt my stream. if I would renice the zip process to 0, that could cause some damage. If I would renice it to -1, that would probably end up badly for the stream. I just stopped it, and we are still at 11.5 gigs. Remove home. Yeah, back to 6 gigs. In this example, the command tar is executed with a niceness of 15. The command renice can be used to change the priority of a running process. The option P indicates the PID number of the target process. For example, renice to -10-P and the process number. Okay, let's practice that. Okay, so the gzip command has a PID number of 10,129. Right, the niceness is 15. And now let's execute this command, invalid priority. What did I do wrong? Renice -10. Okay, sorry. Operation not permitted. Why can't the... I thought that the normal user... Negative niceness will probably do no harm. Tar is single-threaded, so OBS Studio has more than enough CPU cores to run on. Okay, but in general, it could do some damage if it weren't a single-threaded process. But now I'm kind of puzzled. Why can't the normal user renice to a value higher than 0? I thought that I can do that. Oh, because the root started. Sorry, the root started the process. It's not mine. Sorry. Let's renice it. Okay. Old priority 15, new priority 19. Okay. So there we go. Now the 19 is the new priority. We can try. In theory, we can try to put it to -1, but I'm kind of afraid. So I don't wanna. Very nice. Demlan Trap says very nice. Yeah, very nice. The nicest process on the whole computer. Really nice. Yeah, that's what we did, but not with -10. The options -G and -U are used to modify all the processes of a specific group or user respectively. With renice +5 -G users, the niceness of processes owned by users of the group users will be raised in 5. So what can you do with such a command? Can anyone give me any reasonable scenario where the root would want to renice all of the processes of everyone in the group users by 5. Why would you do that? Even for multi-threaded processes, it's not that bad. Those are not real-time priorities, so OBS Studio will still get some CPU time, and maybe it will be enough. Yeah. Demlin Trap says maybe if you have multiple users connected to the server. Yeah, that's what I thought as well. If a team of video decoding is slowing server down, so online shop gets laggy maybe. Some users on a server is using too much CPU, other users are angry. Let's make the user a bit nice. Let's make the user a bit nicer. Yeah. Yeah, pretty much. I am, for the past half a year, I have been thinking about how to replicate a scenario from my teen years when I first heard of Linux, basically. In these years, in the 90s, it was fairly normal that people didn't have personal computers, or if they had, they were weak and usually not connected to the internet and stuff like that, right? So many people would hook up to the university server via terminal, right? You would read email via terminal, you would chat with people via terminal, you would program via terminal, you would play video games via terminal, mod, right? Multiple user dungeon. A lot of stuff had been done via terminal back in the day, and even the university that I went to for the computer access also had X terminals, which were hooked up to the very same server that the text terminals were. So at that time, it was very normal that 100 users would be connected to the server at the same time, maybe more, and all of them would be actively working on the server. Maybe 200 users, not a problem. All of the, what these people would be doing: Pine, Mutt, WitchX, I don't know, GCC, stuff like that. Solaris, yeah, mine was Solaris as well. The one that I used even before I even heard of Linux, it was Solaris on a Sun Spark machine. Iceblade says mine was a bad example, but technical works. Yeah. So for the past half a year, I was the question I asked about this that was from back in from the 90s, right? So if some user is being not nice enough and constantly compiling something and doing whatever and slows down the server for everyone else, then a root user could come and simply renice everything that this user is doing to +5 or whatever, to slow this user down a little bit, and this particular user would probably not even notice the difference or whatever he was doing, right? But everyone else would notice the difference. One user decided to calculate the last number of pi. I once did a pretty bad thing on that server, and I'm not even sure if it's a smart thing to talk about in public, but this particular server was hooked up directly to a network backbone of entire country, pretty much. This particular server that I'm talking about, that everyone was using on that university, um, that particular server had the fastest internet access in the entire country, and I kind of slowed down the network a lot. But yes, the administrator, um, I got my account locked, and I was called to a certain conversation to a certain uh, administrator individual. Also had to promise never to do that again. But yes, you can do all kinds of stuff as a user. I just wanted to say for the past half a year, I was trying to replicate this kind of scenario where we have one single Unix-like server. It really doesn't matter if it's Linux or BSD or whatever, but something modern that many users would use together. It's just that everyone has its own computer at home nowadays, and everyone has its own internet. So having a kind of a public access Unix server doesn't make much sense anymore in the modern times. I just can't find a good enough scenario where anyone would want to connect to someone else's server to do, whatever. Not a BBS. Let me show you. Let me show you. I have a really good example that still works. And it actually has a lot of users. So SDF is a public access Unix system. It has been around for a long time. You can open account there right now and get a shell access. SDF stands for Super Dimension Fortress. You get a Unix shell pretty much. Alexei says, I think our university still has a small cluster for practicing with heavily parallel programming, MPI and stuff. Anyways, the SDF, let me show you. I have an account over there. Where am I now? Here, let's go here. SSH SDF org. I think my username is Dart. Let's give it a try. I haven't connected there for a long time. Permission denied. Maybe that's not my password. Permission denied. SDFEU. Let's go to this one. Oh, there we go. The access server was exactly that. Remote SSH access, multiple users, Vim as default editor. Yeah. So that's the Super Dimension Fortress. They have different servers for Americas, different servers for Europe. I have accounts on both of them. I gave them some money. You can. There is a small donation, like really a funny sum, like $3, and you get permanent access to their server. Really funny price, and you can do stuff on their server, right? Directory and file utilities, email information, Usenet information, user and process information. Let's go with users. Oops. Let's just type who. So these users are online at the moment on the SDF EU server. Yeah, because corn shell is default here. I think I changed it on my other one. Let me check. I just forgot what my password is. Not the password, the user on my other one. The user on my other one is don't remember. Maybe I have some forwarding. Forward. Nah, that's just email. I mean, I know it's email, but I thought that I was forwarding from this one to the American one, but actually I'm forwarding from the American one to the EU one. So now I don't remember which was my username on the other one. Maybe JC. Oh, there we go. My name is JC. Let's see who is on here. Oh, less people here. Interesting. Maybe it's not the evening time for Americans yet, so Iceblood says EM is that public facing email you showed us. Yeah, it is. This one, yeah. Yeah, you can email me on this email address if you want. That's me. No big deal. You can send emails to that. The DuckDuckGo has a pretty good spam filter, so no worries. Let me just type help here. I think I changed my shell to ZSH here, but that's not normal on this server. This is NetBSD, I think. ARPA. F. Telnet, SSH, finger links, who is IRTS, free IRTS, talk, Y, MICQ, all kinds of stuff. You can have your web page. I don't think I can change my shell with this command. No, I can't. There is a different procedure to change my shell. But uname, I think it's NetBSD. Yeah, it is. NetBSD 9.3. Help system is from 1993. So that's more modern than when this was installed. Why you might get spammed by real users? Nah, I don't have a problem with that. Yeah. Anyways, what I was talking about, I'm really worked up over making something similar to this, but there is no way that people would want to join something like that and read their email there. It kind of doesn't make too much sense. Even I am not using this system. Cut dot forward. Oh, this one is forwarding to Witcher as well. I figured I was forwarding from this one to the EU one, but apparently no. Whatever. I think I even had a plan. Oh, not on this one. There we go. That's my plan. That's my plan from when was it? June 17, 2024. So there we have it. I wanted to do something else here. I forgot what was it before I log out. I don't know, I forgot. I guess it's not important. Anyways, let's leave it running for now. Check CPU loads. $350 processes. Load average 1. How many CPUs? How many cores does this thing have? Am I blind? Let's check the other one. Top. This one is not even running. Uname. NetBSD 9.3. And this one. NetBSD 9.1. Press 1. I did, and if I press number 1 while in top, it just... Oh, sorry, I pressed Q. If it's a modern CPU, I suppose it's a 12-core CPU. Sorry. Oh, Xeon. There you have it. Xeon. Let's see. Which year is that? So that's an $900. Oh? Oh, that's two CPUs. Would be 24 core. No, it's multi-threaded. But that's two CPUs. Two Xeons on the same motherboard, each one with 6 cores. Which year is it? 2012. Iceblade says server rack with 2 CPUs on one board. I don't know if it's a rack. It could be a normal tower. Who knows? It could be a normal tower, but the CPU is fairly aged. But then again, it's not very power hungry. Maybe if they have 2 of them in one box. Oh, how much RAM did it say? Not found. Is there RAM? Swap is not being used. Memory 72 gigabytes. What is ACT? Is this like 72 gigabytes used or 36 gigs free? I suppose it has 128 gigs of RAM. I don't understand this output. The other one has a weird output. Oh, the other one is like this, but the last one is processor 7. Okay, this one could be 4 cores if the last one is number 7. Where is the Intel web page? It usually takes me to Intel web page. Let's search. Sorry, I clicked the wrong thing. Xeon X5460. Quad core, yeah. Yeah, I thought so. Weird output. User benchmark. This one is 4 cores. 4 cores. Does it have hyper-threading? I don't know. 4 threads. 4 cores, 4 threads. So the American one also has 2 CPUs. Also has 2 CPUs. grep mem total. This is not Linux, by the way. I'm just saying. Rots mem info. Mem total, that would be 128. That would fall under 128 gigs. Let's see the other one. How much is this? This one has 16 gigs of RAM. Interesting. I always thought that the American... but you know what? They have more of them. They have more of them. You don't get to... You don't connect to the same one every time. Let's look up SDF org. Or maybe you do. I don't know how it works. You have one pending notification. Welcome to SDF public access. Okay. Yeah, I suppose it's just one computer. Anyways, A lot of chat, not too much work. Let's finish this. Besides Renice, the priority of processes can be modified with other programs, like the program top. On the top main screen, the niceness of a process can be modified by pressing R and then the PID number of the process. Okay, let's give it a try. Top. So what is user Dart even doing? Dart is using top. All lessons should have some derailing. Of course, of course. Where is my top? There it is. PID 31289. Was it like this? 39289? It reunites to 1. No such process. I'm waiting for top to appear. 31. Okay. 31289. 31289. 2 1. Did I do it? No, I did. Yeah, there we go. Now it's nice 1. It's nice 1, but it's not using too much power, so it doesn't appear up there. Iceblade says nice. Yeah, indeed. Definitely nice. That's a long one, yeah. PID to renice. The message PID to renice appears with the first listed process selected by default. To change the priority of another process, type its PID and press enter. Then the message renice PID1 to value will appear with the requested PID number, and a new nice value will be assigned. Let me just check if I can. I can't. But if I go to HStop, here I can walk up and down, right? So HStop nice is F7 and F8. So F7, 8. You can see the nice value here. For HTOP, it's already 1. I was just pressing the F8 a couple of times to increase it. Iceblade, you did pipe AVK. What is that? Where did you see that? Oh, Zoran did. Guided exercises. In a preemptive Iceblade, listen up. In a preemptive multitasking system, what happens when a lower priority process is occupying the processor and a higher priority process is queued to be executed? What happens when a lower priority is occupying? You don't understand the question? Okay, let me simplify. So, a process is doing something. It is doing something. And another process is coming and wants to do something on the CPU. But the one that is coming, the new one, has a higher priority. What happens? Well, Zoran already answered, but I just want to know if Iceblade understands both the question and the answer now. So, new process will start first once it had finished first. That sentence is so broken. New process will start first. Yeah, I'm sorry, but your sentence is out of my abilities. I know you mean well, but the way you configure the grammar knocks me out. Derails me a lot. But yeah, basically, if a process with a higher priority comes, it will take over the CPU. Yeah, you can put it in a simpler words, maybe. I don't know. Practice. Consider the following screen of top command. What PIDs have real-time priorities on this screen? Which ones? The question is what PIDs, and the PID 0 doesn't exist. Twelve and 16. Yeah. Consider the following PS listing. Which PID has a higher priority? This is the priority. This is the priority column. This is the process ID. So, which one of these processes has a higher priority? « 12? Yeah, definitely. Most definitely. Maybe they meant highest priority because there are three there is 80 and 60 and minus 40. But okay. After trying to renice a process with the command renice, the following error happens. Failed to set priority, permission denied. What is the probable cause for the error? They forgot -p. You do not own the process. I actually think Iceblade is spot on. I actually think the -p could be the first problem, but I think Iceblade is correct twice. Forgot sudo, yeah. I think Iceblade is double correct on this one. Dash P is missing, and even if they didn't forget dash P, they also could not renice lower than 0 because they're not root. Alexei says, fuck me if I can read that. Kutchu rf b. Okay, I suck at Cyrillic. Message removed. Anyways, I failed to read it. Renice has different meaning for dash p than nice. Oh, so dash p doesn't. So dash p is not necessary. You typed in wrong. Yeah. I already told you I can read some of the Cyrillic, basically Serbian, but I struggled to make words out of those letters. I don't know what's up with my throat. Anyways, if the dash p is not necessary, then what is definitely the truth? The truth is that the user cannot renice to -10. Only root can do that. So that's the probable cause for the error. Kak tvoja familia? Demlan Trap says, see, I can read. I can read when the sentence makes sense. Explorational exercises. Changing process priorities is usually required when a process is occupying too much CPU time. Usually required, yes. Using PS with standard options for printing all system processes in long format. What -- sort flag will sort processes by CPU utilization, increasing order. Okay, so we need to use the PS command and sort processes by CPU utilization. pCPU. I don't have that command. Iceblade says PS -- sort P. No, U CPU. No such thing. Yeah, I was wondering the same, Alexei, but that's the question. That's the question. What does it has to do with priorities? I don't know. Maybe it has to do with which CPU is taking too much CPU time. Let's renice it. Zoran says PS -E -O. Oh, that's the that's the one from the lesson. Okay, I'm gonna copy paste it. Copy paste it. Yeah, it seems to be working. Let me try on my own computer. That one has plenty of processes. So yeah, OBS is still among the first, and then the web browser. Iceblade is still trying. Let's try Iceblade's command. Nope, not good enough. Anyways, Iceblade, no misspelled. I copy paste your comments. Zoran wrote the correct one, so it may be a long one, but it is what it is. Command schedule tool can set all CPU scheduling parameters Linux is capable of or display information for given processes. How can it be used to display the scheduling parameters of process 1750? Also, how can Sketch tool be used to change process 1750 to real time with priority minus 90 as displayed by top? Also, they asked for the flag, not the whole command. They did ask for the flag, but it's an explorational exercise and you're supposed to test it. So the answer is one thing, but the test, the procedure is what it is. My dog just put my wife's bra on her nose and entered the bed for sleeping. Leading dash is wrong. Northern chimp. I don't think I have seen you in chat. So if I missed your previous message, welcome in. Hello, hello. Let's try the sketch tool command. Anyway is the correct answer. Let's try sketch tool to see the scheduling parameters of a random process. Did you hear that? Not sure if my filter on the microphone blocked that sound, that voice. Did not hear it? Okay, good. It's better that you didn't. I just entered. Okay, welcome in. I don't have this command. My Debian wasn't born with the sketch tool command. No command found. Let's see if it's installed here. Will not execute. Yeah, I don't have it. So, what do we do? Do we play with this exercise or not? Let me know. Skip if no one got it. You can install it. If you are an administrator and you need this command, you install it. I mean, that's the last thing we're done for today. There's nothing below this screen. Zoran had to install it. Oops. Let's see if there is a package called that way. Yeah, there is. Okay, now we have it. It's not too late to try it out. Of course, it's not late. So they want us to analyze the scheduling parameters of any process. Scheduling parameters, scheduling policies, sketch tool process IDs, query. So it's just it, right? Let me see. I don't know. Is there anything going on this computer? Not really. Cron maybe? Process 463. So the question was display the scheduling parameters. So that's pretty much it. Scheduling parameters, scheduling normal, nice, 0, affinity, 0 times 3, sketch tool dash F. Really? Is that the answer for the second question? How can sketch tool be used to change process to real time? To minus 90. So minus 90 with the top is which priority? Which priority is that in Linux? It's not minus 90, right? So which one is it? 30? I didn't even try to think about it. The top is... What is top doing? Top is putting everything real time below 0 and everything... Oh, so the difference is 100. So if we want to get minus 90 in top, that would be the actual priority 90, I suppose. Vladimir says, hi folks, sorry I'm late. I've been banging my head on the desk for a while, dealing with the Gentoo. Welcome in, Vladimir. We are pretty much finished. However, I have been late for a full hour, so if that means anything to you. Alexei says 10. The priority 10 is minus 90 in top. Oh, right. Right, you're correct. You're correct. I displayed it in my head a little bit upside down. Top had defaulty 80 then? No, top. It's not about what is default. the question is that we want to put we are not concerned about what is default. We are the ones who are setting the priority. We are deciding which one we want. It doesn't really matter what is the default. We need to set a priority with this tool to a process, and once we start top, it must display -90. So in order for top to display -90, we need to set the priority to, as Alexei said, 10. So what is the way to set priority with this tool? I don't know. Let's find out. So scheduling FIFO, scheduling RR, scheduling ISO, scheduling normal, nice level. Iceblade says -P10, static priority. Okay, okay, good catch. Okay, let's give it a try. Sketch tool, what was the one that we changed priority for? 463? Okay, thanks. -P10 463. So like this, right? I don't think it worked. You need to also set it to real-time class. Okay. You're just guessing? Oh, you're close enough. Let's see what Alexei told us to do. I don't see it. Y-F. Y-F. We are already root. We don't need sudo. I don't have this tool. I'll have to rewatch from beginning later. Oh, okay, Vladimir. It's a fairly easy lesson. We talked a lot. I'm searching for how to make it real time. Oh, never mind. Static was required for -F. Ah, so okay. Now I see. So there are different types of real time. Or am I mistaken? There are two real time schedulers, FIFO and RR. Yeah, that's what I just realized. Yeah. That's why I said there are different kinds. So you can make it first in, first out, or round robin. Okay, let's do the FIFO one then. So this one, right? So dash F. So Iceblade was correct after all. There we go. Let's see what we did. Yeah, now it's priority 10. Okay. So now it's priority 10. And if we fire up top, then 463 should be minus 90. If we could even see it here on this list. Can we scroll down in top? I forgot if it can do that. Top minus P. Nice one. Nice one. However, the priority is minus 11. The priority is minus 11. Why is it not minus 90? Hmm? Why is it not minus 90? What's the screw up? Let's see in htop. Ah, minus 11 as well. Okay, at least htop and top have the same numbers. But why is it not minus 90? Where's the problem? What if I put it to 1? Now it's minus 2. You want to put it to minus 89? Minus 89? You can't go to negative. You can do 90. That's the first thing that I wanted to do. Then Alexei said 10. Ah. Looks like I was correct after all. and not upside down in my head, but not quite correct. Let's do 89 like Iceblade says, but not the negative value. Now it's good. Now it's good. Numbers reversed. So in the beginning, I was thinking that if top changes the value by 100, that's why I was thinking to put 90 to get minus 90. And that kind of made sense in my head. Then Alexis said put 10, and I was, you know, he is always more correct than I am. So I found a new sense in that one. But apparently Iceblade knows how to do it. So should be 89. Should be 89 to get minus 90 in top. Uptime 15 days. We could reboot it for no reason. Update. See if there is anything to update. Full upgrade. Oh, new kernel. Yeah, the number starts at 0, but command starts at 1, so the result was +1. The command doesn't start at 1, but Linux kernel priorities do. And the command as well. So guys and girls, how do you feel about the lesson? Fairly easy? Not easy? Too much talking? Too little talking? Have we been nice today? Alexis says they said that top subtracts the priority value by 100. Let's read it one more time. Sorry, I'm searching for where they introduced top for the first time. Here we are. I'm searching for top. This was the introduction story, right? So Linux has static priorities from 0 to 9, well, from 0 to 139 basically. And then, as shown in the example, the PID init, the standard priority for normal process is 120, so that it can be decreased to to 100. Okay. With command PS. Where's the top? Note, however, the priority value displayed by PS differs from that obtained in the previous example due to historical reasons. Okay. It is also possible to continuously monitor processes with program top. To make it easier to identify real-time process, top subtracts the priority value by 100, thus making all real-time priorities negative. So, yeah, Alexei is correct. Alexei is definitely correct. Minus 90 plus 100 is 10. Thanks, Vladimir, for the message. Yeah, Alexei apparently discovered, I wanted to say a bug, but this is not software, so this is not a typo. This is, the whole sentence is wrong. The whole sentence is wrong. If we have made the priority 89 and that gave us minus 90 on top, so the priority 89 is 11 below 100, right? These are the real-time priorities. So in theory, 89 should be minus 11 in top. But we got minus 11 in top when we put priority to 10. So it's like reversed. Is it reversed? I think I get it. I think I get it. I think the priority scale is turned upside down before top subtracts. Does that make sense? I think it does. So for example, if this is a bit perplexing. Yeah, seems correct. Iceblade says. I have a feeling that Iceblade understands what I'm saying. The priority scale goes from 1 to 139. And the real-time ones start below 100, right? But top doesn't subtract from 100 to minus 100. It kind of flips the scale before it subtracts. I think it makes sense. I would need to calculate it. Let's do it again. I just rebooted this server. Not 6. Why did I press 6? We need a process that runs all the time. Let's make it watch minus n 0.1 ls. Okay. Where's my watch? There it is. Okay, I made the watch command to repeat 10 times per second. That's why it's using so much resources. I just want to have it on the top of the top command. So 917 has priority 20, and priority 20 is basically 120. Now I'm getting slightly puzzled. Priority 20 is definitely 120 on the operating system. So yeah, it does make sense. It does make sense. So priority 20 is 120 on the kernel. So if we want to get minus 90 on top. Okay, I'm starting to understand. Top goes for the normal processes. It goes from 39 to 1 or 0, right? For the normal processes to 0, it goes to 0. And when it goes to -1, that's when it flips. That's when it flips, right? Let me draw it. Now I understand. What can I do for drawing? GIMP. That's not a good program for drawing, but never mind. Actually, GIMP won't fit here. Never mind. Sounds like fun. Actually, let's do it like this. Calc. Let's do it like this. No drawing. No drawing. So kernel. Where am I typing? Kernel top. Okay. Top. No, sorry, not that's not what I wanted to do. Sorry. I wanted to do this, and then we have kernel 139, 138, 137. The kernel one is linear, right? From 1 to 139. Okay, so the left column is correct on its own, right? But the right column is subtracted by 100 until it reaches real time. And now I think it's minus 99. No, not minus 99. Sorry, I meant I'm totally lost. Minus 1 here, right? Let's see if this makes sense. Sebia. Minus 1 was correct. But this still doesn't make too much sense. We have made the process priority 89, right? We've made it 89. We made it 89 and we got minus 90 in top. So this is not it. But even if I reverse it, it's still not it. It still doesn't make sense. Looks like for real time the formula is minus 1 minus priority. Yeah, that's what I was thinking. Once it enters the real time, it no longer matches this. I just couldn't fit how. Let's ask ChatGPT. Explain the difference between Linux kernel real-time priority number and top utility priority number. Why are they different and what is the different formula? Range 1 lowest real time to 99 highest real time used by real time scheduling policies like FIFO and round robin. What are these cookies? Get the hell out of here. So now I can't read because I have cookies here. Whatever. Pick an element. And this one. Delete. There we go. Cookies removed. There wasn't a button to remove cookies. Linux kernel behavior real time tasks preempt normal tasks, higher priority, larger number. Means the task gets CPU access before lower priority real-time tasks. Top range for normal processes priority equals 20 plus nice value. Usually 20 to 39. For real-time processes, priorities are 1 to 99. Are you sure? This is not correct. This is incorrect. Okay. I thought that ChatGPT can do computer stuff, but obviously it cannot. It cannot be trusted even for that. Man, top. Okay. Priority. Priority. Nice value. Priority. Okay. Where's the explanation? Really nice. Priority. There is no more of the word priority. I turned it off. If he doesn't remember anymore. Or maybe I can pull it from history. Is there recently closed tabs or something like that? Alexei, I think this answers all of your questions. So it knows. No questions left. How is it uncommon? Real-time processes with scheduling policies have negative priorities. Yeah, okay, Vladimir, but it doesn't matter that it remembers. Yeah, but large language models often do contradict itself. Watch this exercise now. I'm just gonna say you're incorrect. Let's see what it says. Oh, and if you see a negative value in the PR column of top, that is not normal and it's a bug. Or the terminal is broken. Or the kernel is corrupted. I'm laughing to Iceblade's response. Guys, don't use ChatGPT for learning. It will just confuse you. Ah, can I close ChatGPT? Let's go to sleep. It's time for me. I gotta get up for work in the morning. Holy crap. 262 updates because I wasn't at home for 4 days. If that's the crap you're talking about, or the crap is the one that GPT said, all kinds of contradictions. Good night, Iceblade. That's what 90 gigabyte of SSD write endurance less. Yeah, you can do that every week, even more frequently. I'm kind of looking forward to Trixie. I have some ideas how to make it work for me. Pac-Man. Pac-Man taking over the CPU. Vladimir says, not that I'm promoting any AI, but Copilot is reading all of the crap on GitHub all of the time, so often it has right answer about Linux questions. Okay, but still, all of them hallucinate. It's just a matter of how much. So you gotta keep your common sense while you are helping yourself with using them, right? There is a limit which maybe it may be moving, but I think there will always be some kind of a limit to how much they can handle. If you need to constantly correct them, then in terms of time savings, it kind of becomes questionable. Can you be faster by simply reading the manual with understanding versus just asking the large language model and then correcting it and then correcting it again and then asking it to read the manual instead of you and then trying to understand, is it correct this time, because you're the one who doesn't know. It the time kind of drags, at least in this case. Lachlan H, how can I install Copilot on Linux? You can't. You have to go to Microsoft webpage. Copilot. There you go. Copilot.microsoft.com. Reject. There you have it. There is your Copilot on Linux. Compare Linux top utility priority numbers to Linux kernel priority numbers. Let's see if this one can answer it. The top displays priority. Okay, the formula used to calculate priority is priority equals 20 plus nice. Okay. Linux kernel 0 to 139. Okay. The top utility shows. Okay, kernel real-time priority is not directly visible in top. How is it not directly visible in top? I mean, we have seen that it is visible, but so Vladimir, we have the same problem with Copilot. A priority of minus 90 is unusual. By the way, Vladimir, Copilot is ChatGPT. I mean, it is the exact same technology behind both of them. This is ChatGPT. It may have different training set, maybe. I'm not sure what is the relation between the whatever the company is called, OpenAI and Microsoft, but OpenAI did create Copilot, so it's what I'm saying. While it's the same language model, maybe the raw ChatGPT is not getting all the data that Copilot has access to, like you said, GitHub. It's all about sets. Yeah, it could be. It could be. I understand it, but the technology behind them is literally the same, as I understand. This is literally GPT, which, let's see if it can answer this. Northern Chimp says GPT-4o gave me an invalid command argument earlier on. It is what it is. Let's try. Let's try the Chinese guy. If my computer doesn't break because I have upgraded the kernel moments ago. Sudo. Did I do it right? try DeepSeek. Same question, but this is local DeepSeek. So actually, I'm running DeepSeek Coder, so not sure how many sets this one is missing from the general knowledge. Something is wrong with the speed. It's usually faster. Ah, a drawing is useful. Drawing is always nice. Okay, so default normal priority. This is incorrect. This is not the full DeepSeek model, mind you. I give up. I don't know. Guys and girls, I'm going to bed. Let's continue the next Sunday, right? Thank you very much for hanging out. Chinese dude is going to bed as well. And if you are in my time zone, have a good night. If you are even ahead of me, also have a good night. For you guys in the USA, have a good day, evening. Northern chimp with the penguins. I'm going to see you, in the next video.